Okay guys, so today I'm going to talk to you about inverses, and we've come across the word inverse before. For example, earlier this chapter we had something called the inverse property of addition. You might remember that that was sort of the canceling out property. Alright. For example, a times 1 over a, they cancel out and they equal 1. Oh, sorry, that's multiplication. Addition would be a plus a negative a equals 0. So, though that inverse property of addition or of multiplication just really signals to us how we cancel things out. Well, we can actually have inverses of entire functions or entire relationships. And the really fancy definition of an inverse of an entire function or relationship is this. If a relationship or function, doesn't have to be a function I suppose, consists of the ordered pairs, so just a set of points, x comma y. So if you think about it, all our graphs, any equation, it basically is made up of an infinite number of points with an x coordinate and a y coordinate. The inverse is the set of ordered pairs designated as y comma x. So, here's what you need to notice. We went from x comma y to y comma x. The key thing to remember when you're finding inverses is that you are switching x and y. Now, the video that you're going to watch today doesn't really get so much into how that ties into the inverse property of addition. What we do in class, you'll really see, oh, I see how things would be canceling out. For right now, though, key thing, when you're finding inverses, switch x and y. That's got to be the key thing. Now, if x and y values are switching, then that also means that the domain and range will switch too. We know that the domain is the set of all x's, the range is the set of all y's. So if we're talking about switching x and y, well, those concepts are going to switch too. So what used to be your domain on the original function will become your range on the inverse and vice versa. Again, we'll really get into that more in class, but for right now, know that x and y switch. So easy examples are when relationships come to us in a set of points or a table. In class, we're going to work with sets of points and finding the inverses, but we'll also find the inverses of graphs and equations, but we're going to keep it simple. If I have this set of points, 1, 2, 2, 4, 3, 6, 4, 8. That relationship is a function, by the way. None of the x's repeat themselves, so that's good. But the inverse, it's super easy. To find the inverse, 1, 2 becomes 2, 1. 2, 4 becomes 4, 2. 3, 6 becomes 6, 3. 4, 8 becomes 8, 4. It's as easy as that. We just switch x and y. So same thing over here. Now, this is not a function. Right away I can see that one's paired with 5 and one's paired with 6. But that doesn't mean we can't talk about its inverse. Same thing, 1, 5 becomes 5, 1. 1, 6 becomes 6, 1. 3, 6 becomes 6, 3. And 4, 9 becomes 9, 4. Okay, oops, I didn't realize I was off the screen. There we go. By the way, guys, these squiggly brackets, they just mean the set of, okay, that means the set of, so we're just saying that the inverse is the set of all of those points. Now, sometimes people confuse the word inverse with the these other ideas in math. Okay, so don't do this. Don't confuse inverse with these two words. If you mean to say the word opposite, don't say inverse. If you mean to say the word inverse, don't say opposite. I understand the confusion, but they're actually not the same thing. Okay? Inverse deals with switching x and y. Remember that opposite means change the sign. And reciprocal means flip the fraction. Those ideas may come up when finding the inverse. Okay, but they themselves are not the inverse. These two things are not inverses. Okay, so tomorrow in class, or the next day in class, we're going to definitely dive deeper into inverses, but you got a good introduction right here.